So here we want to use it to construct an ellipse. How do you do that? First of all, divide the rectangular method into with a horizontal and vertical diagonal lines. You can see a vertical and a horizontal diagonal lines. And also note, very importantly, it's always more preferable to make sure that the length of this height is always to third the length of this width. Okay, so you make sure that the length of this width is if the length of the height is always to tell the length of the width. For example, if the width here, if the length here is, for example, let's say 150 millimeter, then the width is more preferable to be 100 millimeter. But if the length here is about 170 millimeter, the width here is more preferable to be about 80 millimeter. Okay, but if here is about 60 millimeter, the length here is always more preferable to be about 90 millimeter, and so on and so forth. So when you have drawn a rectangle with, let's say, a method of 120 and 80 millimeter, then you have to divide this line, the diagonal lines. When you have done that, for you to draw the circle, for you to draw the ellipse, first of all, divide any given equal number of sides here. For example, I can divide from this point to this point, which is going to be 40 millimeter, half of the 80. I can divide into 4 equal parts by drawing from the center point here. I labeled it what? Okay, I labeled it D. Okay, I can draw it from D to 3, D to 2, D to 1, and do the same thing from C to 1, C to 2, and C to 3. And do the same thing the other side, C to 1, C to 2, and C to 3. D to 3, D to 2, and D to 1. This is exactly what I mean. That's it. 3 to D, 2 to D, and 1 to D. On the other side, I did what? C to 1, C to 2, and C to 3. C to 3, C to 2, and C to 1. D to 1, D to 2, and D to 3. You can see I've divided this into 1, 2, 3, 4 equal parts of 10 millimeters, since it's, the total width from this point to the diagonal side is supposed to be 40 millimeters. So I divided for 10 millimeters for easy measurability, but you can divide any given number of equal parts you want. Okay, minimum of 2, maximum of infinity. The more the division, the better. Okay, but just make it for easy readability and easy drawing, and to make a good sketch, you divide something that is reasonable so that people can easily understand what you are doing. Okay, when you have done that, the next thing you are going to do is from C, draw a line that will cross point C and touch point line 3. Please note that you have to divide this diagonal from the center line here, call it 0 to B, divide it also 4 equal parts, since you divide this side into 4 equal parts. Okay, so you do the same thing, divide here from center 0 to 3 will be equal to 3 to 2, will be equal to 2 to 3 to 1, and equal to 1 to B. The same thing is applicable to that side. 0 to 3 will be equal to 3 to 2, 2 to 1, and 1 to A. Then you draw a line that will from 3 touch line 3, from C, point 2, touch line 2, from C, point 1, touch line 1, and do the same thing the other side. Do the same thing from D, touch line point 0, and touch line 3. Do the same thing the other side, D, line 3 to 1 to 3, from D to 2 to line 2, D to 1 to line 1. See what exactly of what I'm saying? Can see it? C point 1 to 1, C point 2 to 2, C point 3 to line 3, C point 3 to line 3, point 2 to line 2, point 1 to line 1. Then from D, you can see the point of intersection is 1, 2, D2 to line 2, D3 to line 3, and then D3 to line 3, D2 to line 2, and D1 to line 1. Okay, now we can form the curvature. You can see the curvature of the ellipse will be from point D to the point of intersection of tangency of line 3, line point 2, where 2 and 2 intersect, 1 and 1 intersect, and this point, 1 and 1 intersect, 2 and 2 intersect, 3 and 3 intersect, 4 point 0, point C, then point 3 intersection, point 2 intersection, point 1, and you form your ellipse. This is exactly what I'm saying. You can see we have a perfect curvature of an ellipse. Okay, don't mind, it's a freehand sketching, so you can see how the ellipse forms. So this is the method you can use to construct an ellipse. Okay, then let's see the steps you can use to construct the ellipse. Draw a rectangular major and minor axis. You can see it, the major and the minor axis. I call it height and width or length, height and length, but you can call it major and minor axis. It's not still yet bad. So when you have done that, in the triangle both axes, draw the perpendicular line, the bisection line, or you call it the diagonal line, or the perpendicular bisection of each other, anyone you know, but just know that it's just to divide the length into 2 equal parts, and the minor axis into 2 equal parts. So when you have done that, you label the sides, label every side. So when you have done that, then you draw your curvature, draw the line, and then draw your curvature, and then you can get your perfect ellipse. So this is a method of constructing of an ellipse using a concentric circle method. Okay, so if you have any other further questions, you feel free to contact me or to send a feedback or notification on my YouTube channel so that we can deal with it, and I can help you to answer any other kind of question you wish to. So thank you. Today we are going to still talk about another rectangular method you can use to construct an ellipse. It's a new method I think is necessary for you to use. It's also easier and better to construct, but if you feel like, you can still use your previous method. So the method is, first of all, draw your rectangle, major and minor axis of the rectangle, bisect the diagonals of a perpendicular bisector of the line. Okay, the major and the minor. Here I am still adopting a length that is about 120-80 millimeter. Then you label each other, A, B, and CD. Then you join the lines, divide into 12 equal parts, then join them. You can see I'm joining them. When you have finished joining them, watch. I draw the same measurement or the same angle from the same angle I have here. I will come here and measure it, draw the same length here, and produce it here. The same radius from point 1 to 1. I'll produce the same radius with the same angle to here. Do the same thing in 2. The same angle that is here will be the same angle I have here, and then the same radius from point 2 to 2 will produce from this point 2 with the same angle here. Do the same thing in 3, 2, and 1. And then use a perpendicular line. A straight line that must be actually perfect vertical to join 1 to 1, 2 to 2, 3 to 3, 3 to 3, 1 to 2 to 2, and 1 to 1. So this will give me the curvature of the ellipse. So you can see we join them and we have a perfect curvature of an ellipse. So that is it. These are the steps. If you want to